For this first question, I would like to simplify the following expressions, and we want to review our radical expressions and equations. So in order to simplify a radical equation, we need like radicals. So what I want to do is simplify root 27 into 9 times 3, root 12 into 4 times 3, 32 would be 16 times 2, and 8 would be 4 times 2. So I'm simplifying, then I'm going to take out the perfect square factor, the largest perfect square factor from each of those numbers, which the first one would be 3 root 3, plus 2 root 3, minus 4 root 2, minus 2 root 2. And when we combine those, we get a 5 root 3 minus 6 root 2. For question B, square root of 98 simplifies into 49 times 2. 20 is 4 times 5. 18 is 9 times 2. So we get 7 root 2 minus 2 root 5 plus 3 root 2. And 7 and 3 is, of course, 10 root 2 minus 2 root 5. And that's as simplified as it can get. Okay, for the next ones, we want to distribute, just as we would with the regular polynomial. So we get 2 times 6 minus root 30, which is 12 minus root 30. For question D, I'd like to FOIL. We get 4 minus 4 root 12 plus root 27 minus, big number, 27 times 12. So I'm going to do this two ways because I'm just realizing as I write this, I could have made my life easier. 27 times 12, which is 324. Is that a perfect square? It is 18. So of course we get 4 minus 4 times 4 times 3. And 27 is 9 times 3 minus 18. So we end up here with 4 minus 18, which is a negative 14, minus 4 times 2 root 3 plus 3 root 3, which our final answer should be negative 14, and negative 8 plus 3, which is going to be a minus 5 root 3. Okay, we could have done this one another way. Had I simplified the 27 and the 12 to begin with, I could have also done D like this, 4 plus 3 root 3 times by 1 minus 2 root 3. We should get the same answer, 4 minus 8 root 3 plus 3 root 3 minus 6 times 3. So we get 4 minus 5 root 3, take away 18, which is of course negative 14 minus 5 root 3. Okay, we've done it two different ways. And just keep in mind when you're multiplying, you multiply the coefficients and you multiply the radicals separately. Okay? So for question D here, the second way we simplified first. All right, how to rationalize a denominator. We know that we want a rational denominator. We need to get rid of that radical whenever it's in the denominator. So if I look at this first question, the issue here lies with the root 3. The 4 is fine, so I don't worry about the 4. We multiply by root 3 over root 3. And when we multiply that straight off, 96 times 3 is, of course, 288. Now, 288, I might simplify 96 first. Let's simplify that 96 first. Then we're not having to simplify 288. Okay, sorry about that. So if we simplify this 96, I know that 4 goes in there for sure, as does, I believe, 16. Right? 96 divided by 16 is 6. So that's 16 times 6 over 4 root 3, which is 4 root 6 over 4 root 3. Oh, and actually look what happens here, guys. The 4's cancel, and root 6 divided by root 3 is root 2. Okay, so things made it a lot easier if we simplified first. Okay, let's look at question B. So I know that both of these are divisible by 3 for sure, these radicals. And 150 divided by 3 is 50, and 72 divided by 3 is 24. Looks like we could have probably divided by 16, or 6 rather. But if we keep going further, we get 2 root 25. Right, I divided by 3, and I divided by 3. And I'm just going to divide one more time by 2 and 2. We get 2 root 25 over square root of 12, which is, of course, 2 times 5 over 2 root 3. Those 2's cancel. I still need to rationalize by multiplying by a root 3 over root 3, so we get 5 root 3 over 3. Okay? The next one, again, is a monomial denominator. We're going to multiply by root 2 over root 2. The only difference here is I need to distribute. So we get square root of 14 minus 2 all over 2. And remember that it's so tempting to want to do this. So tempting to want to simplify those two 2's, but that does not work with multiplying. And of course, we can think an example through if we had like 4 quarters plus, 2 quarters, and they're all quarters. 4 plus 2 quarters, that is definitely not equal to $2, right? That is incorrect. So I definitely cannot simplify like that. That would be 6 quarters, right? I'd have 6 quarters, or 3 halves of $1, or 1/50, right? $1.50. So definitely do not do this, okay? Do not do this here. All right. This next one, again, we're going to multiply by root 6 over root 6, and distributing backwards, we get our root 30 plus root 12 all over 6. And square root of 30 cannot be simplified, but we can simplify root 12 into 2 root 3 all over 6. And that should be our final answer. If we look at the next one, we want to rationalize a binomial denominator. So what we want to do is use the binomial conjugate. So I'm going to multiply by a 4 plus root 14 over 4 plus root 14. And when I distribute across here, our numerator becomes 4 root 7 plus whatever 7 times 14 is. I think that's 84. 7 times 14. 98. Nice try, Schwartz. 98. Okay. Our denominator, the shortcut is, of course, that this is going to be a squared minus b squared, right? Because this is an a minus b, a plus b, difference of squares situation. So our shortcut is that this is 4 squared minus square root of 14 squared, which is 4 root 7 plus 7 root 2, because 98 is 49 times 2, all over 16 minus 14, which is 4 root 7 plus 7 root 2, all over 2. Okay, again, this next one, we want to again multiply by the binomial conjugate, which would be 3 minus root 10 over 3 minus root 10. And this one here, of course, is a little bit trickier because we're going to have to FOIL, right? We FOIL 4 times. We multiply 4 times as opposed to just twice like the last one. So when we FOIL that out, we get 15 minus 5 root 10 minus 3 root 10 plus 10. Root 10 times root 10 is, of course, 10 all over 3 squared minus root 10 squared. So we end up with 25 minus 8 root 10 all over 9 minus 10, which is negative 1. So we end up with an 8 root 10 minus 25 over 1. And how I did that is if I factor out a -1 here. On my numerator, and I get a -1 denominator, what's going to happen is these two guys are going to cancel. And we get 8 root 10 minus 25. Had we left this as 25 minus 8 root 10 over -1, that would have been fine as well. It's okay. But typically, mathematicians like to write things with as few negatives as possible, so they would factor that negative out of the numerator and cancel with the denominator. Okay, solve the following radical equations. So the whole trick here is that we isolate the radical. Okay. Isolate the radical. That's first, then we square both sides. Okay, and if you forget to isolate the radical, things get dicey very quickly. Okay, so let's isolate this radical. Okay, and so we know that the square root of 2y plus 3 is equal to 4. We also have a restriction on this variable that we know that 2y plus 3 must be greater than or equal to 0. So 2y must be greater than or equal to -3, and y greater than or equal to -3 over 2. So now that we've isolated and we have that restriction identified, then we're going to square both sides. And on our left-hand side, we get 2y plus 3, and our right-hand side, we get equals to 16. Okay, that's a 2 there, a variable of 2. So we now have a simple 2y equals 13, divide both sides by 2, so y is 6.5. Okay, and if we were to do a check there, square root 2 times 6.5 plus 3 minus 4 should be equal to 0. Right? Is it? Let's check. That's 13 plus 3, which is 16. And the square root of 16 minus 4 is 0. So left side equals right side. Okay, so we've done a check as well. Again, for question B, let's move over this 4. And we know that the square root of x minus 2 is equal to x minus 4. And so our restrictions here, we know that for our restrictions here, we know that x minus 2 underneath the radical has to be greater than or equal to 0, so x has to be greater than or equal to 2. And x minus 4 also has to be greater than or equal to 0, so x actually has to be greater than or equal to 4. Right, there's an inherent little restriction here. That value, right, has to be greater than or equal to 0 because the square root of x minus 2 has to be a positive number. So now we are going to square both sides. And on our left-hand side, we get x minus 2. On our right-hand side, we get x squared minus 8x plus 16. And for this one, it looks like we're going to have to factor. Okay, and we want factors of 18 that add up to -6. So those are x minus 6 and x minus 3. So x is equal to 6 and x is equal to 3. And I can see by this restriction here, the 6 is not going to work. Okay, I can also do a check there. 4 plus the square root of 6 minus 2 should be equal to 6. Okay, and if we do a left side check there, that's a 4 plus 2. Oh, and of course, sorry, oops, I actually crossed off the wrong one. Oops, the x minus 4, sorry. X has to be greater than or equal to 4, so this one is going to work, okay? This one here is not going to work, okay? So anyway, sorry, the answer there is 6, and then my right hand side is 6. So my left side is equal to my right side. But here we get an x equals 3, so let's just see what happens with that one. We're pretty sure it's not going to work because x has to be greater than or equal to 4. I know it's not going to work, but let's just double check. We get a 4 plus the square root of 3 minus 2, and that should be equal to 3. And if we kind of finalize that check there, we get our left-hand side. On our left-hand side there, we get 4 plus 3 minus oh, 3 minus 2, that should be 3 minus 2 in our equation, sorry. 3 minus 2, which is a 1, square root of 1, which is 1, and 4 plus 1 is 5. So 5 does not equal to 3. Left side does not equal to right side, so we know that our final answer is x equals 6, and this other one is extraneous. Okay? Sorry for that rough end there. Anyway, if you have any questions or concerns, please do not hesitate to ask. Thank you.